Hello, good morning. Am I audible?
Yes, sir.
Okay,
Yes,
thank you.
sir. Yes, sir.
Yeah. Uh, so last class, this is what we understood how to insert a new node in between two nodes. Okay. Uh, so first thing is you need to take a pointer which is pointing to this node, and there has to be one more pointer which is pointing to this, and this is the new node. Okay. So say this is new node, and say I have so p uh, tr is pointing to this, and okay, ptr1 is pointing to this. So what we do now, to insert this new node in between these two, uh, see address of this node, new node, should be stored here. Now how do we do that? So using this ptr, I need to access this field. After accessing this field, so I have to store address of this node. Now how to do it? So ptr arrow link is equal to new. Okay, ptr arrow link is equal to new. So that means address of this node gets stored here. And next what you have to do, so once address of this node is stored here, this link is broken. That means from this node you cannot reach this. If from this node you can reach this. Next, address of this node should be stored here. Now how to do that? So new arrow where address of this node should be stored here. So you got to access this field now. New arrow link is equal to ptr1. New arrow link is equal to ptr1. This is how we do it. Understood now? Is this clear till here?
Yes, sir.
Yes, sir.
Okay. Now, so now this is one example what you understood how to insert a node. Correct now? After some node. Okay. Next, are the three cases possible. So we don't always go for inserting a node in between, correct? No? After some node. Sometimes we also go for inserting at the beginning. Sometimes we go for inserting after a given node. So this is what we understood. Inserting this node after the cat node. Okay. And sometimes we also go for inserting into the sorted list. Okay, now we are going to discuss each one of them in detail, okay, along with the algorithm, okay, and how to do it. Okay, so first we'll learn how to do inserting at the beginning. Okay, now for inserting, say this is before looking into this algorithm, so have a look into this pictorial representation. So this is my existing list, singly linked list. Okay, we have the start pointing to it. Don't worry about this part right now. Okay, I have the start pointing to the first node, and this is the link, existing link. Now I need to add a new link to the beginning. Okay, so to the beginning of the list I need to add. Now what I have to do, I have to create a new node. See, so this is the new node which I'm creating. After creating this new node, I'll assign the info field, I'll assign the I'll assign the info field, and since I have to make this node as the first node, what is that I have to do now? So earlier, before this node was created, this node was the first node. Now I've created this node, and since this should be inserted at the beginning, correct, no? This node will become the new node, or the starting node, next starting node, or the beginning node. What is that I have to do now? In the next link field of this new node which is created, I have to store the address of this node here. Okay, and then after storing address of this node here, I have to make start. See, start was initially pointing to this because this was the beginning node. Now this is no longer the beginning node, so this is the beginning node. Now I have to make start to point to this. OP people are following?
Yes, sir.
Okay. See how to do that here. Insert first, ins first. So the name of the function or the algorithm what I've taken is ins first. Okay. Now what I'm passing, info I'm passing, because after creating the new node I got to assign the info field, and then the link, and then the start, because start, you know, it will always be pointing to the beginning node of the linked list, and then the item to be inserted. Okay, item to be inserted. Now what I'm doing, so I'm creating a new node, create a new node. Now, and what is the name I'm giving to that? New is equal to node. Say for example, when I make a call to this node, so there is a new node created, and once the new node is created, so address of that node is returned to new. What does this mean? So this is the new node that is created, and address of that new node is returned to new. That means new is pointing to this. Hope you people understood what node function is doing. It creates a node which can hold info field and the link field, and address of this node is returned by the node and it gets assigned to new. It's nothing but new is pointing to the newly created node. Hope you people understood?
Yes, sir.
Yeah, let me write here. Okay, so this is my existing list, already existing list. I'll take 3 nodes. Instead of word list, let me take it, and this is null. I have already told you, if I need not write it as null, even if I put this, it's null. And here, let me make it as a list of integers. 1, sorry, 2, 3, and we have start pointing to this first node always. Start is pointing to this. Okay, now I want to insert a new node to the beginning here. Okay, what is that I have to do? I have to create a new node. So I'll make a call to node. When I make a call to node, a new node is created. Okay, now a new node is created and 2 fields are there inside it, info field and one is the link field. Next what I do, once node is created, this node returns the address of this node to assigns the address of this node to new. Now what does it mean? New is pointing to this. OP people understood? Yes or no? New is pointing to this means what? New is holding the address of this node. Is that clear till here?
Yes, sir.
Yeah, this is my already existing list, and this is what the new node I have created. Now I got to insert this new node here, the beginning. Now what does that I have to do? Before inserting, see, observe now, new arrow info is equal to item, say 0. Now the item value is 0. This is what I need to insert now. Okay, now where I have to put this 0 in my new node? In this field. How to access this? New arrow info field is this, correct, right? I am assigning what? 0. Getting? And what is that I have to store here? Tell me. Hello? What is that I need to store in the link field of the new node?
Address of the next
Address of which node?
Next node.
Next node. What is the next node here? Address of the starting node or the beginning node in the already existing list. Yes or no?
Yes, sir.
Yeah.
Yes, sir.
Now, how to get the address of the starting node now, or the beginning node of the already existing list, or which variable is holding the address of the starting node?
Start.
Start. Now how to do this? See, you can access this field. this field. In this field, you have to store address of this node. Now, to access this field, new arrow link. Is that correct? Step 3. Observe step 3. New arrow link. Is that correct? You have accessed this field. Is equal to start. What's happening? Address of this node gets stored over here. Understood? That means you get a link like this. Is this correct?
Yes, sir.
Yeah. Next. Now, this node is no longer a beginning node or a starting node to this list now. Yes or no? Start should always point where? To the beginning node. Now, this is the beginning node now. Now, to make start to point to this. Now, start was holding address of this node. Now, you have to make start to hold the address of the new node. How to do it? It's very simple. Start is equal to new. You're assigning the address that is there in new to what? Start. Now, the once this statement gets executed, the start is no longer pointing to this. The start comes and points to this. Hope you understood?
Yes, sir.
Yeah, this is how you can add a given node to the beginning of a singly linked list. Okay, right now there are 2 pointers. So this node right now can be accessed by using start also, and it can be accessed by using new also. Say if I go for creating one more new node, say I want to insert one more new node beginning to this. What is that I have to do now? I'll go for creating a new node. The moment I create a new node, so new pointer will take the address of the new node that is created. Understood? So, but as of now, so new is also pointing to this node and start is also pointing to this node. If I go for inserting one more new node, so new will be automatically pointing to that new node which is created. Hope you people understood how to insert a given node at the beginning of a linked list. Is that clear?
Yes, sir.
Yeah. Next. So this I've already told you, okay, how to insert in between. Now the same thing, we are going to discuss along with the algorithm. Okay, insert after a given node or insert after a given location. Okay, so location will be given to you, and you should go for inserting after that location. The new node should be inserted after that location. So just focus now. Okay, so this is my already existing list. Okay, and this is what I need to insert, and what you have to do I've already told you. Okay, observe. So let us go with the algorithm now. Okay, or so instead of this, okay, let me write my own list. Let me take a list with 4 nodes. Okay, this is null since this is the last node. I'll make this as 1. I'll make this as 2. I'll make this as 4. I intentionally I'll skip 3, and then I'll make this as 5. Now I'll insert 3, a new node 3, and start is pointing to this. Start is pointing to this. Now I want to insert a new node 3. So after at location 3, okay, so or after 2 I need to insert after a given node. Say after 2 I need to insert. What I'll do so say first observe here, info field, link field, start, this is what I'm passing. Location also I'm passing. What is the location? 2. 2 is the location. After 2 I need to insert. An item to be inserted is 3. Okay, so I want to create a new node now. To insert an item 3 between 2 and 4, what is that I have to do? I have to create a new node. Let me create a new node here. I make a call to the node, function node. It allocates a memory for the new node, and address of this memory is returned to new. Now new is pointing to this. New is pointing to this. And after that, what is that I have to do? Now after the new node is created and new is pointing to this, now using new, I access the info field. So info field I'm accessing and I'm assigning my item. Now item is 3 right now. I want to insert 3. Okay. To this place I'm assigning 3. Hope you understood till here.
Yes, sir.
Okay. Next. So after doing this, I'm checking location is 2 right now. Okay, location is pointing to this. Say for example, location is a pointer, and if location is equal to null, so I'm checking. So if the already existing list is null, assume there is no list itself. Okay, then set new arrow link is equal to start, and start is equal to new. Okay, so new arrow link is equal to start and start is equal to new. That means this itself is the first node. Hope you people are following. Yes or no?
Yes, sir.
See,
Yes, sir.
so this itself is the first node. New arrow link is equal to start. So if there is no link existing, what will be the start? Start will be null, right? So assume this list is not there. So if this list itself is not there, what is the status of the start? Is start null?
Yes, sir.
Yes. Observe now. If location is equal to null, that means the list itself is null. Okay. What you do? The new node what you have created. I'm writing here. This is the new node. New node. Here you write the info field. And this field, what is that I have to do? If this itself is the first node, I have to make it as null, right? So new arrow link is equal to start. What is the start? Null it is. Okay. And make, now you have created one node. Okay, this is the first node. And start should always point to what? The first node. Make start is equal to new. Now start is pointing to this. Correct now? Yes or no? Any doubts here?
No, sir.
Okay, next. If the list is not null, okay, so I have already existing. Now go to the else part. Now what is that I have to do? See location. I assume location is pointing to this LOC. Now how to make LOC point to this, I've already told you in the previous class. So first make location is equal to start and keep incrementing the location until you get the desired position. Okay. Now I wanted to keep increment till it reaches the node with the info field 2. Now let us assume location is pointing to this. Now what is that I have to do? New arrow link is equal to location. Okay. Now what I'm doing, new arrow link, observe now, this is new field or new node, arrow link, this field is equal to location arrow link. If I assume location is pointing to this, location arrow link is what? What address it is? Which node address it is?
Next node.
What is that? Now you got to tell me the number. Tell by info field.
4.
4. See here. New arrow link is this field. Now I want to store something here in this field. What is that I need to store? What is that I need to store?
Address of
If I'm inserting this node between these two, what should come here? Address of?
4th.
4. Next, this node. Address of this node should come here. Address of the node with info field 4 should come here. Now how to do that? See here. New arrow link is equal to location arrow link. Location is pointing to this node. Now using this location, if I access this field, in this field already address of this node is stored. Correct now? You get it. Now what you're doing, you're storing address of this node here. Okay, so something like this. Next, what is the other thing you have to do? What is the other thing you have to do? In this field, correct? No? Yes or no?
Store the address.
Address of new.
Yes.
So how to access
New
this
in-
field? Location arrow link. Correct, right? Location arrow link. This field you have accessed is equal to new. Now see, now the current status, what it is saying is you can reach this node from here also. From 2 also you can go to this. From 3 also you can go to this. Yes or no? But now I need to break this link. I need to break this link, and here I need to put address of this node. What is that I have to do? I am breaking this by saying location arrow link is equal to new. Address of this node gets stored over here. Hope you understood.
Yes, sir.
So this is how you got to do when you want to insert a node after a given node. Okay, next. Similarly, now how to insert into the sorted list? Okay, say I have to write the example for this. Let me write. Okay, I'll take this as 1, I'll take this as 2, I'll take this as 4, 3 I'll skip, and I'll take this as 5, and this I'll make it as null. Okay, now I want to insert 3. Okay, I want to insert the node 3. Okay, let me start from here. Now insert info link start and item I'm passing. The item which I want to insert is 3 now. Okay, now first I want to find the address. Okay, so info link start item and location I'm passing. Now here, now what we are discussing is find A I'm discussing, and insert into location is already here. So the same algorithm what we have understood in the previous slide. Observe now, first finding the address. See, this procedure finds the LOC location of the last node in the in a sorted list such that info location arrow info is less than the item. Okay, less than the item to be inserted, or sets a location is equal to null. Say for example I want to insert the node with the 3 now. Okay, finds the location of the last node in the sorted list such that location arrow info is less than the item. The item which I want to insert is 3. Okay, now I'll check the info field. Can you know 3 with 1? Yeah, 1 is less than 3. Again I'll proceed to the next. I'll check with 2. 2 is less than 3. Again I'll proceed to the next. Okay, now I check 4 with 3. Yeah, 4 is not less than 3. I stop. Okay, now that means I understood. So this is the place where I need to insert my new element. Now how to do that? Observe here. First I check if the list is empty, start is null, and then location is also null. This itself is the first node. Otherwise I check my item. See, this is my item. Item is nothing but this the element to be inserted. Okay, item is less than start arrow info. I'm checking 3 is less than start arrow info, then set the location to null and return, because item is lesser than the start itself. That means it has to be inserted at the beginning itself. Okay, otherwise set trail is equal to start. Now I'm making, so start was pointing to this, start is pointing to this. I'm taking one more pointer with the name trail is equal to start. Now trail is also pointing to this. So I cannot write it neatly, just observe. So trail is also point, because I've told trail is equal to start. Now trail is also pointing to the same node to which start was pointing. And then observe now, PTR is equal to start arrow link. Following? Now where PTR will point? Tell me.
Next node.
Next node. So
2.
PTR is pointing to 2. PTR. Okay. So PTR is pointing to the next node. When PTR is pointing to the next node, trail will be pointing to the node which is just previous to that. Hence the name what we have given as trail. OP people understood?
Yes, sir.
Okay. Now see, if PTR is pointing to this 4, now trail will be pointing to just previous to that node. Okay. Hence it is called as trail. Okay. Now, so this statement is clear. Now what we do now? Repeat 5 and 6 while PTR not equal to null. So this step, these to 5 and 6 step, you got to repeat until PTR is not equal to null. I'm just checking now. PTR, is it null?
No, sir.
PTR is not null. What I do now? Again, I'll go for comparing. Okay. So item less than PTR arrow info. So item is 3. I want to insert 3. Okay. I'm checking whether 3 is less than PTR arrow info. That is 2. Okay. Is the condition true? 3 less than
False.
2. False it is. That means don't do this. Okay. Don't do this. Come to this. Okay. Set trail is equal to PTR. Because that means, so this is not the place where I need to insert 3. Now what is that I have to do? Trail is equal to PTR. Where trail will point now? Where trail points? 2. It points to 2. Yeah, this is not pointing here. Trail points to this. And then what is that you have to do for the PTR? Trail is pointing to this, and PTR is equal to PTR arrow link. Correct? No? PTR should be made to point to the next node. How to make it point to the next node? PTR is equal to PTR arrow link. Okay. Now this PTR moves here and it is pointing to this. Is that clear?
Yes, sir.
Yeah. Now go back again. Okay. So it says repeat 5 and 6 while PTR not equal to null. Again I'm checking. Is PTR equal to null? Not equal to null? Yes. True. PTR is not equal to null. Now again I check. Item is less than PTR arrow info. What is my item? 3. Correct, right? 3 less than
Yes.
PTR arrow info. 4. 3 less than 4. True it is. What is that you have to do now? So you have to make location is equal to trail. So trail was pointing to this. Yes or no? Now location is equal to trail. If I do, location also points to this. Is it clear?
Yes, sir.
That means you got the node after which the new node should be inserted. Understood? Now the new node 3, it should be inserted after the node to which location is pointing. Is that clear?
Yes, sir.
And then what it does, it returns. After making location is equal to trail, it returns. After returning, so that means I have found the address after which the new node should be inserted. Find A is done. Now after that, I just do this. Insert, location I call, info field I'm passing, link field I'm passing, start field I'm passing, and then location. What is this location? Location is pointing to 2. That also I'm passing, and item to be inserted 3 also I'm passing. Now it goes to this algorithm. Okay, everything is passed. Now it creates a new node. So the new node what I've created is what? This 3, correct, right? And new is pointing to this. Now what I'm doing, location is already pointing to 2. Now I go for inserting. What I do, address of this node I'll store here, and address of this node I'll store here. OP people understood? Correct? Address of this node I'll store here, and address of this new node it gets stored here. and this link is broken. Hope you people understood.
Yes, sir.
In this algorithm, it was not clear. I told you, assume location is pointing to this. But with this algorithm, you understood how the location came to this point. Yes or no?
Yes, sir.
Yeah. So make trail to point to the start node and take one more pointer PTR. Just make PTR to point to the next node after trail. Okay, and check whether PTR is not equal to null. And one more condition, what is that you have to, if PTR is not equal to null, then go for comparing item with the info field of the PTR. So if it is lesser, so you got the location. If it is greater, then again make trail to point to the PTR and just increment PTR to point to the next node, and just compare again whether item is less than info field of PTR. So like this, and once item is less, you find that the item is less than the info field of the PTR, so you got the location is equal to trail, the position you obtained, and insert it between those two nodes. Okay, clear, right? Okay, shall I move to the next?
Yes, sir.
Okay, now, so linked list, so you have understood it. Now what it is, an ordered sequence of node with links. Okay, so an ordered sequence of node with links, and nodes do not reside in sequential locations. Okay, so here it looks like it is sequential, one after the other, correct? No? So that means say this is at address 1000 and this is at address, since it is integer, so this is at address 1000 and this is at address 1004. No, it won't be like that. So they can be present anywhere inside the memory, correct? No, so the nodes are not residing sequentially inside the memory. The locations of the node may change on different runs. Say for example, first time I execute the program, so I may get different addresses, so some addresses, and second time if I run the same program with the same nodes, so the addresses may be different because the addresses get allocated to us dynamically during execution time. Okay, now this is how it looks, something like so. And we have one more list here, or I can call it as one more node with the name while. Now what this while says is any point of time this will tell how many more nodes can be added. Say for example, the maximum capacity I've defined, I can have 8 nodes. Okay, so this what I'm showing here is representing the info field, and this is the link field. So pictorially we represented it like this, but memory, this is how it gets stored. See, I have the start, okay, and whose address is what, 7, okay, here, and what it is holding, the info field. So the address of the starting node is 7 and the info field is X, and it is pointing to what, the next node 4. Okay, next node address is what, 4. I go to the address 4, there I'll find T, and the same node, the node which is present at address 4 is holding the info field T, and it is next pointing to the next node which is present at address 2. I go to address 2. Okay, so and at address 2 the node is holding the info field as A, and next it is and 0 indicates it's null. Okay, it's null. This is the last node. Okay, now, and this while holds the what number of empty locations. Right now, see, while is this. How many empty locations are there? 1, 2, 3, 4, 5. Okay, so available is 5 empty locations, something like this, and this is how it is stored inside the memory. Okay, and then memory allocation and garbage collection. Okay, a special list which is maintained for unused memory cells is called as available list. That is what I told you, available list. Unused memory locations are what? 1, 2, 3, 4, 5. Okay, so and there is a 5 here. That means So it maintains the list of unused memory cells, and it's called as available list. And the operating system of the computer periodically collects all the deleted spaces into this free space storage list. Okay, it will accumulate. So periodically what OS will be doing is it will be collecting the details of all the spaces that are deleted, and it will create the free storage list. So the technique that does this is called as garbage collection. Okay, so because whenever required memory is required, the memory should be allocated, and whenever the memory is not required, it should be left to the free storage list, such that the memory location is available for the next process which is executing. Next, applications of linked list. Now you can go for using the singly linked list for inserting after, deleting after, performing the insert after and delete after operations, and you can also go for inserting at the beginning. Okay, now the other important applications of the single linked list is you can go for using singly linked list to implement the stacks. So stacks can be implemented as singly linked list. Now you can go for implementing queues using the singly linked list, and you can also go for evaluating or implementing the polynomial using the singly linked list. Okay, now we'll understand how to implement the polynomials using the singly linked list. So when I say polynomial, so it will be having the coefficient, it will be having an exponent, and we have a link. So since I have to represent a polynomial using a singly linked list, now two fields are not sufficient for me. So I require three fields. So one field for holding the coefficient, another field for holding the exponent, and one more field for holding the address of the next node. OP people understood? See, till now what we understood was a node with two fields, info field and a link field. So now I have three fields here. So I should be going for creating a node with how many fields? Three fields. One field for holding the coefficient, another field for holding the exponent, and one more field for holding the link. Okay, so these two basically forms the information field right now, and this is the field for holding the address of the next node. Okay, so polynomials. Now to represent the polynomials, I should be going for creating a node with three fields now. One for holding the coefficient, one for holding the exponent, and one for holding the address of the next node, or holding the link for the next node. Okay, representation, something like this. So this is the pictorial representation, and the same thing when you are implementing it using the programming language. So I'll create something like this: struct polynode, polynomial node. So it should have three things. One is the one for holding the coefficient, one for holding the exponent, and one for holding the link of the next node itself. It's a self-referential pointer, a pointer to the node itself. Okay, and using type def, I am just creating an alternative name to this structure with poly pointer. Now using this poly pointer, I can go for declaring any number of variable to this structure. So right now using poly pointer, which is a type def definition for this structure, I've created three variables or three pointers. A, B, C are pointers to this. Hope it's clear.
Yes, sir.
Okay, now observe. Now this is an example of how to represent. Say I have one polynomial, a is equal to this. Okay, 3x to the power 14 plus 2x to the power 8 plus 1. Now how it is stored. See how it is represented using a singly linked list with a node of three fields. See, so I'll take this 3x to the power 14. 3 is what? The coefficient stored in this field, and what is the exponent? 14 stored here, and this field for holding the address of the next node. Now if I go to the next node, see what is it? 2x to the power 8, 2 and then 8. Am I audible?
Yes, sir.
Okay, 2, 8 and the next field. Okay, next, the last one is only 1. okay, which is only the coefficient. Coefficient is 1, and exponent x to the power 0, it's something like that. X to the power 0 is nothing but what? It is 1, okay. Exponent is 0, and this is the null. And similarly for b, you can just observe here another polynomial I have. So for this first term, the coefficient is 8 and exponent is what? 14, and this is holding address of the next node. If I just go to the next node, so the coefficient is -3, okay. I'm writing it as -3, and its exponent is 10, and then holding the address of the next node, and next thing is coefficient again 10 and exponent is 6. Hope you people understood how to represent a polynomial using a singly linked list of 3 fields.
Yes, sir.
Okay, so we'll go to the next one. Now adding polynomials. Say I want to add 2 polynomials. So I have taken the same polynomials. This is a and this is b. I have taken the same. Okay, this is a and this is b. Now I want to add the polynomials. Now what I'm doing, see this node and this node. Okay, I'm taking. I'm just checking. So how do I access the exponent field? Exponent field of first polynomial, a arrow exponent, similar to how we solved it in the previous slides. Yes or no? So a arrow exponent accesses this field, and then how do I access the exponent field of the other polynomial, b arrow exponent? Now when I say a arrow exponent, what is its value? 14 equal to b arrow exponent, so that is also 14, correct? No? If exponents are equal, okay, if exponents are same, what is that you have to do? You have to add the corresponding coefficients. 3 plus 8, how much it is? 11, and the exponents remains the same. Okay, exponent remains the same, and then you should go for incrementing both a as well as b. If exponents are same, add the corresponding coefficients and increment a and b. Now if I increment a, so a points to the next node, and if I increment b, b also points to the next node. So this is that is what the status you are seeing here. Understood? A is also incremented and made to point to the next node, and b is also incremented and made to point to the next node. Hope you people understood till here. What you're discussing now is adding 2 polynomials. Now I take the exponent of the second term, okay, from the first polynomial. How much it is? 8. A arrow exponent 8 I got, and then I access the exponent of the second polynomial, b arrow exponent. Now what I'm observing now is the exponents are not same. This is 8 and this is 10. The 8 a arrow exponent is less than b arrow exponent. Okay, if that is the case, okay, you always go for taking the next term in the polynomial addition is what? The term which has the greater exponent. Now which term has the greater exponent? The term in the b polynomial has the greater exponent. Okay, because a arrow exponent is less than b arrow exponent. Now I just write here in my final resultant polynomial -3 10. Okay, now why -3 10? So because you should go for writing that node which has, or that term which has greater exponent. Okay, so -3 10. Now what we do? So -3 10 we do, and we only increment b, and we make this the pointer of the first polynomial still point to this node itself. A will be pointing here itself, and we just increment only b, and b is made to point to this. Okay, I'll go to the next one. Now my resultant polynomial is this till now. Now observe, a is still pointing here only, and b is incremented and it's pointing. Now I'm comparing exponent of a with exponent of b, that is 8 and this is 6. So 8 again in my next term of my resultant polynomial will always go with what? The term which has the highest exponentiation. Now among these two, among this and this, which has the highest exponentiation? This one. Now 2, 8 I'm writing, and then I go for incrementing only a. Okay, only a is incremented and made to point to the next node, and b is still pointing to this itself. Next. Okay, and in the next thing, what happens? I go for comparing the exponentiations again. A is also pointing to this, and b is also pointing to this. A is also pointing to this, b is also pointing to this. I compare the exponentiation. Whose exponentiation is greater? So this. Now I write. So 10, 6. The next node will become. Okay, sorry. I cannot go with. See, I do this, and next time when I'm doing, so I've reached the null. If you reach null of any one of the polynomial, you have to stop the process. So since I've already reached the null of this, I'm stopping the process. Okay, I stop here. And the implementation for the same. OP people understood how to do it, how to do the addition of two polynomials, how to represent the polynomial, and how to do the addition of two polynomials.
Yes, sir.
If exponents are equal, what is that you do? You add the coefficients, okay, and increment both a and b. If the exponent of in the next, if exponents are not same in the resultant polynomial, you go for writing the term with the highest exponentiation and increment only that pointer, and the other one should be left there itself. Okay, so that this is the logic and implementation for the same. You can just observe here. So poly pointer polynomial p add is nothing but polynomial addition. I have two pointers, pointer a and pointer b. A is pointing to one polynomial and b is pointing to another polynomial. Now here again, okay, this is all fine. I'm checking whether it is full or not. Just focus here. I'm just saying front is equal to rear, and while a and b, see, this is what is important. See, both should be true, correct? So this should also be not null, and this should also be not null. If any one is null, okay, we stop the process. Now initially, when you are starting here, a is also not null, b is also not null. So we get into this and we switch compare. We compare exponent of a and exponent of b. If both are same, what they return? They return 0. Okay. If exponent of a is less than exponent b, what compare returns? -1. If exponent of a is greater than exponent of b, it returns 1. Okay. If it is equal, what I'm doing, observe now. So first let me go with the case 0. If exponent of a and exponent of b are same, what we are doing? We are adding the coefficients. Corresponding coefficients are added and we attach the sum, okay, sum and a exponent to the rear of the new list what I am creating, and after doing that, both a and b are made to point to the next terms. See, a is equal to a arrow link and b is equal to b arrow link. OP people following?
Yes, sir.
Yes, sir. Similarly, if exponent a is less than exponent b, what we do? See, so b coefficient we attach and b exponent we attach. We choose the term which has higher exponent. If a is lesser than b, now I go for attaching b's coefficient and b's exponent to the rear, and what we increment? We increment only b. So b is equal to b arrow link, and a we don't modify. And similarly, case 1, we attach a exponent, a coefficient and a exponent, and we go for incrementing only a and not b. Clear? I hope you people understood till here. Any doubts till here?
No, sir.
Okay. Okay, next is, okay, and then what we do, uh, finally, see, after doing all these things, so till the nodes reach the end, see, for A, and there is no initialization, A, and A is equal to A arrow link. What we do, if A is not null, so we attach the A coefficient and A exponentiation to the rear, and similarly till B reaches the end, so we attach it, okay, and finally we make the rear as null. Okay, so this is what the simple algorithm for adding two polynomials. So if you have understood this, what I've told you, then this algorithm you can easily understand. So why we have taken -1 0 and 1 here? See, compare, I've already told you when we discussed string, there we use the built-in function compare. What compare does, if two strings pointed, strings are same, what compare returns is 0. Okay, when you're comparing two strings, if the strings are same, it returns 0. If the first string is bigger than the second string, it returns 1. If the first string is lesser than the second string, it returns -1. Okay, so on that basis these cases are written. Next, representing polynomials as circular linked list. So you understood queues and then you understood circular queues. Similarly, circular singly linked list is also possible. Now what we were doing here, so the last node, the link field, we used to store it as null, and this is not necessary now. So you don't have to make it as null. Now instead of storing null here, you just go for storing the address of the first node here. Okay, so if I just store the address of this node here, what does it mean? Okay, from this node I can go back to what? The first node. Okay, people understood? It makes a circle. See, I'll just remove this null and I store address of this node here. What does it mean? From this, sorry, discount. I'll remove this null and address of first node I'll store here. It's nothing but from this node I can go back to the first node. What it is? A circular singly linked list. Correct? So that is what I'm trying to explain here. Is that clear? Hello?
Yes, sir.
Okay. See here. So when I create a first node, okay, first node, see, so this is the node which I'm creating. Here I'll go for this is 0 polynomial, okay, or an empty polynomial, what I can say. So in this field I'll store the coefficient, in this field I store the exponent, and this, instead of making null, I'm making it to point to itself. Okay, next, when there are other nodes also, okay, so this just to mean it as the starting node, or you can also call it as header node. Okay, so I'm just taking this. Okay, now here what I'll do, so I'll make A to permanently point to this header node. Okay, and now the link field of this header node is pointing to the first term of my polynomial. 3 is the coefficient, 14 is the exponent. It goes like this. And the last node, okay, instead of making it as null, here I'm storing the address of the first node. Okay, and this is a special node called as an header node, which is always the starting node. And for this node, okay, we are not taking any exponent, and we have just made it as -1. Okay, understood? So this is a circular, representing polynomials as circular linked list. Okay, and we have the implementation of the same an algorithm, and then how to represent the sparse matrix. Sparse matrix you have already understood. Now how to represent the sparse matrix using again circular linked list. So this is how it looks, the sparse matrix representation circular linked list representation of the sparse matrix we'll discuss, and then we will start with the doubly linked list. Now I just want to stop here for today, and tomorrow I'll just continue from this point, representing the polynomials as circular linked list and its algorithm. So if you have any doubts till here, you can ask me. So meantime, I'll finish taking the attendance. Any doubts?
No, sir, no doubt.
Okay. Uh, 350 350 is there. Yashash V.
Yes, sir.
Yeah, see, your proctor is Nikita madam.
Okay, sir.
No, you contact madam, okay? You have madam's number?
No, sir.
Okay. And I think I am proctor for C3 batch. C3 batch students are here. C3
Yes,
batch
sir.
students,
Yes,
can you
sir.
tell who is your proctor? Who is your proctor? Is it me?
You.
Yeah,
Yes,
okay.
sir.
I have to conduct one meeting with you people. I think I'm a little bit slow in this. Okay. By tomorrow evening, I'll finish one meeting. I think tomorrow we will have it from 6 to 6:30, half an hour meeting. Okay. I'll just put a message in the group. Okay. All C3 batches tomorrow 6 to 6:30. Okay. Just attend. Okay. We'll discuss. Yashashvi.
Sir, regarding what, sir?
Yeah.
It's regarding what, sir?
Regarding no, that is just the counseling. So because all C3 batch students come under me, just to counsel, just to know your difficulties and all these things. Okay. So you can speak with me openly, and if you are facing any difficulty, so and any of the courses, any of the subject which you're discussing, you can discuss with open heart with me during that time.
Okay, sir.
Okay. Yashashvi, you want madam's number?
Yes, sir.
Because she told me to inform you. 1 second. I'll give. Note down. 9743
Yes, sir.
92
Yes, sir.
52
Yes, sir.
82.
Okay.
Yeah, call madam. She has informed me to inform you. I am informed. Okay.
Okay.
So Yashasvi is there, 43 is there, 135 is there, 156 is there, 10 is there, 16 is there, 39 is there. 116, 134, 135, 136, 137.
So he just got disconnected from class, sir.
Yeah,
He got disconnected from class, he said.
he was there. Was he there?
Yeah, he was there. Yeah, he was there, sir.
Okay.
He got disconnected from class. He just told me that.
Okay. Thank you. 138, 140, 141, 142. Uh, 143, 144, 145, 146, 147, 148, 149. 152, 153, 154, 155, 156, 157. Suhas R. 158, 159, 160, 162, 164, 165, 166, 168, 169, 170 is not there. 170, 171. Okay. 171 is there. 172, 174, 175, 176, 177, 178, 179, 180, 181. Two, 183, 184, 185. 185 is not there. 186, 188, 189, 190, 190 is also not there. 191, 192, 193 absent. Okay, if you don't have any doubts, okay, we'll end the meeting here, and I think the other batch has the lab now. We'll start the lab session. So thank you all.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you.